Welcome back everyone, Patrick here. Moving on to the next example dealing with trigonometry. What we have to do is take each of these triangles, just two triangles, one is drawn out, this one is described in words, and we have to solve the triangles. And what solving the triangles means is we have to find all of the parameters for the triangle. So all of the sides, all of the angles. So notice that with this first triangle here, we are given all three sides. And so what we're going to have to do is basically solve the three different angles right here. That's all the parameters that's left to solve. Now, whenever you're given a triangle with only sides and you have to solve for one of the angles, what do you have to use? You have to use the cosine law. We can't use the sine law here because we don't have a pair of an angle and an opposite side. We don't have any of the angles, right? We only have the three sides. And whenever you're given a non-right angle triangle with only three sides, you have to use the cosine law to find one of the angles. And then once you have one of those angles, then you can use the sine law if you prefer. So we have to first use the cosine law to solve for one of these angles. And you can pick any. Remember that with the cosine law, what you have to make sure is that when you set it up, this angle, capital A, and this side A have to be opposite to each other, right? So if you're solving for an angle here, what you have to make sure is on the left side here of the cosine law is going to be the opposite side to that angle that you're solving. Okay, I'm using these letters. You can use any letters you want here. They're just arbitrary. So if this was B over here and you instead switch put the A here, put the B here, this would have to be angle B, right? It will be cos B. Okay, but it's usually standard to just have it like this. But you just have to make sure that this side is opposite to this angle all the time. And so from here, you can pretty much choose which angle you want to solve for. Let's say we want to solve for this angle. We'll call it theta. Well, what's the opposite side to that angle? It's the 10. So the 10 would have to go here. And then this here would be the cos theta that we are solving, like that. Right? This would be the opposite side to the angle we're solving. Now let's say that instead, let's say we're solving for this angle alpha. Well, what's the opposite side to the angle alpha? It's the 18. So then this would have to be 18, like this. And then this here would be cos alpha, like that. Right? So just those are the two most important things, or it's the most important thing, getting those two parameters in line. The angle you're solving for, this has to be the opposite side to the angle. And then the B and the C, it doesn't matter whatever two sides are remaining. Those are interchangeable. But what's not interchangeable is the angle and the opposite side that goes here. Okay, I'm going to stick with solving for the theta first. So this angle, meaning that this left side is going to be 10 squared, the opposite side squared. And then again, the B and the C, they're interchangeable. The sides that are left is the 12 and the 18. So this would be like 12 squared plus 18 squared minus 2 times 12 times 18, like that. And so from here, what you want to do is you want to isolate for this cos theta here. So what I'm going to do, I'm going to bring the 12 squared over, the 18 squared over. So we'll have 10 squared minus 12 squared minus 18 squared. And that's going to equal, what's left here is the negative 2 times the 12 times the 18 times the cos theta, like that. And then we want to get the cos theta by itself, so we would divide both sides by basically the negative 2, the 12, and the 18. Divide this side by that, and divide this side by that, like there. And so notice these cancel out, and now we have the cos theta by itself. And so after you do that, you would get the numerator here being negative 368. The denominator would be the negative 432. So if we continue this here, and you get the decimal of these, the negatives cancel out, you get a positive, and this would give you approximately 0.852. So that's going to be cos theta. And then if you want to get the theta by itself, you would do cos inverse of this ratio, 0.852, which is going to give you approximately 31.6 degrees. I'm going to round it to the nearest degree, 32 degrees. If you want to be a little bit more exact, you can round it to 1 or 2 decimal places. I'm going to round it to 32. I'm going to round it to the nearest degree right there, right? So this here would end up being 32 degrees, that theta that we solved for. And now you have more flexibility in terms of solving for the other two angles with what you could do. Now, personally, I prefer the sine law to the cosine law. Whenever I could use it, I always try to use that instead of the cosine law. To start, we couldn't use the sine law, right? Because we didn't have a pair of an angle and the opposite side, but now we do. So now we can use the sine law to solve for one of the other angles. But initially, we did have to start with the cosine law. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. But now let's solve for this angle alpha here. To solve for that angle, I'm going to use the sine law because we have now that 32 degrees and the opposite side. So we could set that up doing sine of 32 over 10 equals sine of alpha, the angle we're solving for, over its opposite side, which is 18. Now again, you can solve for this angle alpha with the cosine law again. It's just on that left side of the cosine law, you'd now have 18 squared. And then those other two interchangeable sides would be the 12 and 10. So other ways you can solve for this angle alpha, you can use the cosine law if you want. Perhaps it's a good exercise to see if you do get the same angle using the sine law and the cosine law. You should get the same angle. But for this example, I'm just going to be using the sine law here. So what do? Cross multiply. So we'll have 10 times sine alpha equals 18 times sine of 32. And then we can what? Divide both sides by 10 in order to get that sine of alpha on its own. And when you do that calculation, you'd end up with 0.9539. And then to get the alpha on its own, you would basically do sine inverse of this ratio. And if you did that, you'd get approximately 72.5 degrees. I'm going to round it to the nearest degree. So that's just going to be 73 degrees. Right? So this here is 73 degrees, that angle alpha right there. Again, if you do that with cosine law, you should get the same angle. And now to solve for this last angle, let's call it, you could put any variable here you want, let's call it x. Well, notice all three angles have to add up to 180, so it's just easiest to subtract 180, or to subtract 73 and 32 from 180 to get that third angle. Okay, and when you do that, you'd get what? This would be 105, so this would be 75 degrees. That would be that third angle. And again, if you want to practice the algebra for the cosine law and the sine law, you could set this up as the sine law. You could go sine x over 12 equals sine 32 over 10. Right? We've done a lot of rounding here, so if you kept everything to more decimal places the whole time, everything should match more closely. So it might be slightly off with the different methods you use because of the rounding, but it should be fairly close. So whichever way you do it, this third angle would be that 75 degrees. All right, and we solved the entire triangle. We have all three sides. We got all three angles. So that's it for part A. Now in part B, Notice we have another triangle, but it's described in words. And so, as I've shown in previous videos, what I recommend doing is drawing out a triangle. Now, notice we're using the letters A, B, C. That's not always going to happen, but in this case, we're using the standard A, B, C letters. So with that, we could say capital A, this is angle A, this is angle B, this is angle C, and then the opposite side to angle capital A is going to be small a. The opposite side to capital B or angle B is going to be small b. The opposite side to angle C is going to be small c, like that. Okay, and so from here, we can now label what we're given, what parameters we're given. Well, we're given 6. The b value here is 10, and then we're given the c value here of 11. So it's actually the same kind of case as this triangle where we're given all 3 sides and no angle. So we are going to have to start with the cosine law to solve for one of the angles. We can't start with the sine law because we don't have a pair of an angle and an opposite side. We only have all 3 sides. So again, you can pick any of these angles to start. I'm going to pick this angle right here. We'll call it angle, well, it's already labeled angle B. So you know what? Let's actually just keep the letter, instead of putting theta here, I'll just keep it as capital B. Now, if we're solving for this angle, if that's going to be the variable in the cosine law, on the left side of the cosine law, we got to use the opposite side, which is this 10 over here. So the way we would set this up is we go 10 squared equals the other 2 sides, the sum of the other 2 sides, the square, or the sum of the squares of the other 2 sides, minus 2 times 11 times 6 times cos of b. We're solving for that cos b right there. And if you do the same process, bring the 11 squared over, 6 squared over, divide both sides by negative 2 times 11 times 6, what you would end up with is basically 10 squared minus 11 squared minus 6 squared divided by negative 2 times 11 times 6, like that. And when you do the algebra here, you'd end up with negative 57 for the numerator, negative 132. You divide those, you get this ratio of 0.4318. And then we're solving for b, the angle b, so that would be cos inverse of that ratio right there. And if you do that, if we round, you'd get approximately 64 degrees. It'd be like 64.4 if you want to be more exact. I'll just leave it as 64 degrees. So that's going to be this right here. This here is going to be 64 degrees. That's going to be angle B. And then from there, we have more flexibility with how to solve the other angles. We could again use sine law or cosine law. I'm going to use sine law. Again, that's always my preference. If possible, I use sine law. And in this case, it is possible because we're given an angle, or we have an angle, and the opposite side. And so we could solve for C or A. Let's solve for angle A. So we'll go sine A over the opposite side of angle A, which is the 6, like that. And so from here, what we would do is basically cross multiply. Actually, you know what? Let me cross multiply these on the left side. So we'll have 10 times sine A like this equals 6 times sine of 64. Divide both sides by 10 in order to get the sine A by itself. And then if you do that calculation here on the right side, you'd end up with this ratio. And then if we want to get the A by itself, we would do sine inverse of that ratio, which would give us, it would be approximately like 32.6 degrees. I'll again round it to 33 degrees. You could keep it as more decimals if you want to be more exact. I'll leave it as 33. Perhaps when you're doing like your textbook work, it might be better to leave it a few decimal places because then it affects your calculations for the other parameters. And then it could start being a little bit more off than what the textbook gets, and you might start stressing out a bit. So if you do want to keep it more exact throughout the whole process, the likelihood of you having much different answers than textbook decreases. Okay, but again, just for the purpose of this video, I'll leave it to the nearest degree. So that's going to be 33 degrees. And then we just have this angle C to solve for. Well, since we have the other two angles, we could just take those two angles and subtract those angles from 180. So this would be 180 minus what? This would be 97. So this would be 83, like that. So angle C here, this angle would be 83 degrees. And notice now we solved the entire triangle. We have all three sides, all three angles. Okay, so if you're given triangles where you have all three sides, as we've mentioned before, you'll have to use the cosine law in order to solve one of the angles. And then once you have one of the angles, one of the three angles, then you get a little bit more flexibility, whether you want to use the sine law or the cosine law to solve for the other angle. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.